reminding me. So 6.5, question number 17 and 25. 6.6, question number 19 and 29. So these are the few questions here. If you have any questions, please let me know here. Jason, change your numbers, your name. So is that Jason again? Yep. Your number is that Jason or someone else? Henry, sorry, Henry, your change on the number. So let's talk about this. Let me share the screen. Where was that? There you go. So I'm going to talk about 6.5 first, and then after that we do 6.6. So we'll talk about this 6.5, question number 17 and 25. So 17. So this is how we do question number 17 is you have to graph the 5 cosecant 4x. So in order for you to graph the cosecant, you need to graph the reciprocal first. So does anyone know what is the reciprocal of cosecant?
Sine.
Sine. Yep. So you have to graph the 5 sine 4x. So this is, and again, when we graph this, we know the amplitude. Your amplitude here in this case is 5, right? So we are graphing this first, and after that we do the cosecant. And period in this case is 2 pi over b, and b in this case is what? 4, right? This is your b. So when you reduce this, this is pi half. We don't have phase shift because we don't have c in this case, and we don't have d, the up and down, because there's nothing over there. So in this case, we are just doing your amplitude and your period is changed. So now we will graph the sine graph. And as you know that when you graph the sine graph, you need to have the 5 original coordinates. Can someone tell me what is the 5 original coordinates for sine?
0, 0.
0, 0.
Pi over 2, 1.
Yep, go up 1. Yep.
Pi, 0.
Back to 0.
3 pi over 2, negative 1.
Very good, Sally. Last one.
And then pi over 0, or pi 0.
Pi.
Sorry.
Yep,
2
2
pi.
This time, don't worry about that. No problem. So this is, and then you begin to figure out what is your beginning and your ending point, where you have to use your bx minus c equals to 0, and your bx minus c in this case is just 4x. So you will make 4x equals to 0, and then you make 4x equals to 2 pi. The reason why we make it equals to 0 and 2 pi here is because that is their one cycle. Okay, so that's why we use 0, 2 pi, and then you divide. You solve for x, so this is 0. You divide by 4, so you start at 0 actually, and then you divide by 4 here. You will get pi over 2. So this will ends at. So that means that it's telling us this graph will start at 0, and it ends at pi over 2. And now we have to figure out how the other x values. So what you do is you take the period divided by 4. So period in this case is pi over 2. And you divide this by 4. Pi over 2 came from here. Again, this is the same thing as division by 4. But as you guys know that when you divide with fractions, I can change the division to become fractions. This 4, you flip it, right? So this is actually is pi over 8. So pi times 1 is pi, 2 times 4 is 8. So you have to add pi over 8 to each one of this. So when you add 0 with pi over 8, you get pi over 8. When you add pi over 8 with pi over 8, you get 2 pi over 8. But 2 pi over 8 can be reduced to become pi over 4. And then the next one is 3 pi over 8. And then it's 2 pi plus pi is 3 pi. And the next one is 4 pi over 8. 4 pi over 8 is the same thing as pi over 2. So this is how you figure out all your x values. This is what you did in last section. Now we figure out what is your y value. So in order for you to figure out what is your y value, you have to multiply this with a, and then you add d. But the good news is we don't have d in this case. So you just need to multiply this by a. So take all your y values here and multiply this by 5. 0 times 5 is still 0. 1 times 5 is 5. 0 times 5 is 0. This is -1. So when you multiply by 5, you get -5. And then this is 0. So this last, the last 5 coordinates is your coordinates for the sine wave that you have to graph. So you just need to graph this. So I will graph 0, 0. And then pi over 8 will be 5 all the way up there. And then pi over 4 will be back to 0. And then 3 pi over 8 will be at -5. And then pi over 2 will be back to 0. So you will get yourself a sine wave, which is a valley, a hill, and a valley. And then if you want some more, you can just continue drawing another hill and another valley. Okay, this will be at pi, because the whole cycle, the whole period here is pi over 2. So half plus half, you get the whole 1. Okay, and this one will be 3 pi over 4, 3/4, because every hump or every hill or valley is a quarter. So a quarter plus a quarter plus a quarter plus a quarter. So this is the sine wave, but the question here does not ask us for sine wave, it's asking for cosecant. So in this case, you have to give me your horizontal asymptote, which is at 5 and -5. And you also have to give me your vertical asymptote. In this case, is all the x values, x-intercept. So those students who have problems with finding your vertical asymptote, I always tell my students it's always the x-intercept before it moves up and down. So make sure that you understand it when it's not including up and down. So once you move up and down, your x-intercept will move up and down. Okay. So you notice that this is a nice valley. So this will be a hill. So the red ink pen that I draw here will be your cosecant graph. So when I ask this in your test, make sure that you have, a lot of students ask me, do I need to draw my asymptotes if I ask you to draw a cosecant graph? A lot of students ask me, do I need to draw this dashed line? The answer is yes. So in my test, you will have to draw all this vertical asymptote and all your horizontal asymptote using dashed line. And then after that, the reason why you need this dashed line is to make sure that the graph is bounded by these two asymptotes. That means you cannot go wider or narrower. It has to be bounded by those two. That means you have to go parallel against it. So that is kind of like a little measurements. So this is and make sure that this touches at 5 and -5. So this red graph is the graph. So can someone tell me which one looks the same as this? You can tell by the asymptotes. I think they're all in pi over 8. So this will be the correct answer, because they're all in pi over 8 form. Okay, so this is pi over 8. So your answer in this case will be B. Anyone have any questions? 25. Yep, I'm going over that question. Yep. All right, are you guys all right with this one? Again, I've told you again in your test, this kind of questions is coming out and it's not going to be multiple choice. So make sure you guys know how to do all these things. You guys with me here? And I told you before in your test, this is cost like what, 12 points? And you also have to tell me the domain and range here. You guys remember that? Okay. Does anyone know what is the domain in this case? Domain. All real numbers except what? Do we have a phase shift here? We don't have a phase shift, right? So you do not need to put any phase shift, but what you do with the period here. You guys know this?
Would it be like pi over 2, and then it would be like n or like a k?
Yep. So in this case, it's just what we use k pi over 2. But do not forget that if I call you to sine, is this. But what happens if I call you to cosecant is you have to divide this by 2 again. Why you need to divide by 2 is because sine, you get the whole thing, but cosecant, you only need partial. So you need either up and down. So you divide by 2 here. So your real answer in this case is k pi over 4. Okay, so this is very special for cosecant. You make sure you have to divide that by 2, but for sine, it's just k pi over 2. Okay, you do not need to divide by 2 because we take the whole up and down. But for cosecant, up will consider one cycle, down is considered the other cycle. So you have to divide this by 2. Range, anyone know what is a range in this case? It goes
negative infinity to -5.
Bracket,
included,
yeah. Union.
And then 5 to infinity.
Yep. So this is how you figure out your domain and range. So make sure you guys know how to do this, because in your test I will tell you it's coming up. Okay. So I will leave this here. So if you want to take a picture, you can go ahead and take a picture. Well, I'm going to go question 25, which yes. In order for you to do question 25, you need a unit circle approach, the circle one. Okay. So remember the circle. So I'm gonna, everyone good with this? Okay, I'm gonna go with 25 here. And again, you can always watch this again. 25 is this one. So you have to find what is the equation for the interval from -2 pi to 2 pi. For this tangent x is -√3. So what you need to do here is, if you have a unit circle approach, you have to figure out which one of this when you divide, because you are doing tangent, is y over x. So if you take y over x on each one of on 30, 45, 60, can you tell me which one of this will give me a square root of 3? So when you divide these two out, if you take 1/2, sorry, I need to get a new. So if you take the 1/2 and you because it's y over by √3/2, this will cancel out. So this is become 1 over √3, which is √3/3. Unfortunately, it's not the same as this. So it's not going to be 30 degrees. 45 degrees, when you divide this, is exactly what? You will get exactly 1. So tangent 30 degrees will give you this, tangent 45. But 60 degrees, if you find a tangent 60 degrees, again, 60 degrees is this one. So if you divide √3/2 over by 1/2, this 2 will cancel out, you get √3. So this is good. So your answer is 60 degrees. Or in other words, is pi over 3. Okay. So your answer is, answering this is pi over 3. But pi over 3 is wrong. The reason why pi over 3 is wrong is because this is not √3. This is a negative √3. Okay, so 60 degrees is wrong. Can someone tell me what quadrant make tangent negative?
2 and 4.
2 and 4, yes, 2 and 4 will make it negative. So can someone tell me what is the reference angle for 60 degrees for quadrant 2? You can use your unit circle. 60 degrees is this one. Which one is also in
2 pi over 3.
2 pi over 3 or 120, right? So this is, again, we use radian. Same thing in a test, we don't use rate degree. And how about quadrant 4? Which one is quadrant 4 that correspond to 60 degrees? It's always over 3. So which one here is over 3? Which is 5 pi over 3. Okay. So this is, so you got 2 pi over 3 and 5 pi over, this is your answer. But this question is asking us between negative 2 pi to 2 pi. What you give it to me is from 0 to 2 pi. This answer is from 0 to 2 pi. Okay, so now we need to figure out the negative one. So this is back in the first chapter. Do you remember the coterminal angles? If I say 45 degrees is find me a coterminal angle that is positive and negative to this. Do you guys remember this on the first homework in 6.1? How do you find the coterminal angles? Anyone remember?
If it's an angle, you add or minus 360.
Yep,
And if
you're
it's a
correct.
radian,
Yep.
you add or minus 2 pi.
But this time it's going to be radian. So if it's a radian, what you do with it? You add, subtract what?
2 pi.
2 pi. So in order for us, so this is positive. So what is missing here is the negative. You got a positive one. So now in order for you to find the negative one, you just need to subtract 2 pi. So can someone tell me what happens when you take 2 pi over 3 subtract 2 pi? You guys know how to do this?
Do you change it to?
This is over 1, right?
Yeah, and then you change it to 6 pi over 3.
Yep, very good. This is 6 pi over 3. So what is that going to be?
Negative 4 pi over 3.
Yep. I'm going to circle all the answer. This is answer. This is an answer. This is an answer. And then you do the same thing on this case. You get what? Negative pi over 3. So this is an answer. So how many answers do you have for this case? You will have 4 answers. 2 of them are positive and 2 of them will be negative. Okay. This is very important is because when in 7.3 in next week class, we'll be talking about this. And in 7.3, we just want the positive answers. So 0 to 2 pi. So that means you only get 2 answers. But in this section, you have to go 4 answers because it go from negative 2 pi to 2 pi. Okay. You guys all right here with this one?
Do you do one more?
Yeah. Is that 6.5? Samsung, can you tell me which one is it?
Yeah, it's 6.5. Number 26.
26. So this one is the same thing. So in order for you to do 26, you do cotangent. Since tangent is y over x, cotangent will be x over y. So again, you have to use a unit circle approach for this case. Can someone tell me which one you divide here will give us 1? We ignore the negative first, we do 1 first. So can someone tell me what cotangent, when you divide these 2 out, x and y, you will get 1? 30, 45, or 60?
45.
45, or in this case, it's pi over 4, right? Okay. But again, because of this question doesn't ask us for 1, this question asks us for negative 1. So can someone tell me what quadrant is cotangent is negative? It's the same as tangent, right? Which is quadrant 2 and also quadrant what? 4, because this is 2. So can someone tell me what is 45 degrees of pi over 4 in quadrant 2?
Three pi over 4.
3 pi over 4. And what about in quadrant 4?
7 pi over 4.
7 pi over 4. So these are the 2 answers. And then again, because they are positive, remember what happens to find a negative? You have to subtract what? 2 pi.
Wait a minute. Why are we doing quadrant 4?
Because cotangent is negative in quadrant 2 and quadrant 4.
Oh, is it the same as tan?
Yeah.
Oh, okay.
Remember the thing I told you before? All students takes calculus.
Yeah.
So negative is quadrant 2 and quadrant 4. Okay. And then you subtract this by 2 pi and you will get negative pi over 4 here. And I think
Why do we
you
have
get
to subtract by 2 pi?
Because you want it to, because this question is asking us to do from negative 2 pi to 2 pi. So what you find out, this 2 rate 1 answer is going positive.
Oh, okay.
And then the negative one, you have to go clockwise. And in order for us to find the clockwise, we subtract 2 pi, like a terminal angles. So this will give me negative, is that 5 pi over 4? So again,
Yes.
how many answers we have here? You will have 4 answers. 2 of them is positive and 2 of them is negative. I'm going to give you one more time to do this. You guys going to do this for me. So this is something that is important, as I say, is in the test that you will take. By the way, when is your test?
February 23rd.
23rd, which is 2 weeks from today. Okay. It will be cover all this that you have. So I want you guys to figure out what is sine theta. And I need you to do what is the negative square root of 3 over 2. And your theta has to be from negative 2 pi to 2 pi. So figure this one out on your own here. What is theta in this case? And again, class, how many answers you should give it to me? You should give me 4 answers. 2 of them has to be positive. 2 of them have to be negative. Please use a unit circle approach to help you. Private chat me. Don't send it out to everyone to see it. I want everyone here to do it because this is your test. This is your test. Yep. I will ask you this kind of questions in your test. And you can change if you want class, you can always change this to I need 6 trigonometric, and then you can change this number to one of these numbers. Anyone know what this is? Can someone tell me which angle will give us square root of 3 over 2 for sine?
60.
Yep, 60, because this is square of is y, sine is y. So it's 60 degrees. So theta in this case is pi over 3. But that is given us for positive, but this is a negative. So what quadrant you will need to tell me when it's negative? For
3,
sine.
3, 4.
Quadrant what and quadrant what? Forget all students takes calculus. So
3.
which one is quadrant? What makes
3
it
and
negative?
4. Quadrant
Yep.
3 and 4.
Yep, 3 and 4. You're correct. That is correct. Yep, Matthew, that is. Oh, that was really good. Yeah, that is correct. So quadrant 3. Yep. Oh, yeah. And yeah. So this is just a little bit helping you. Yep. Go ahead and yep. So you did it already. Yep. Matthew is correct. And D is correct. Yep. That is correct. Adam. Yep. Private message me. Don't private everyone. So I don't want people to see the answer. That's correct. Alex is wrong. 2 pi over 3 is in quadrant 2. I want quadrant 3 and quadrant 4. You do 2 and 4, not 3 and 4. So Alex, can you redo it? Sally, you also get it wrong. We are not over 6. Over 6 is 30 degrees. We have to be over 3. So can you change it to over 3? So everything, yours is 30 degrees. Not 60 degrees corresponding. So Sally, that is all wrong. Alex, you get me the wrong one. Sam, I need 4 answers. You need to give me 2. That 2 answer is correct. I need 4 answers. Okay, class, You have 4 answers here. Type pi for pi. Okay. Anyone? This is one of the test questions, so make sure you guys know. So in quadrant number 3, pi over 3, which is 60, anything over 3. So it will be 4 pi over 3. Yep. And also 5 pi over 3. Yes, that's correct. 4 pi over 3 and 5 pi over 3. But this is just the positive one. So how do we figure out the negative one? As what I just mentioned early on. Yep, Katie. Yep, you have to subtract 2 pi. You got a positive, so you do have a, yep. So your answer in this case, when you subtract 2 pi, this will become negative 2 pi over 3. And this will become negative pi over 3. So your answer in this case will be, what was that at? 4 pi over 3, 5 pi over 3, negative 2 pi over 3, and negative pi over 3. So this is your answer in this case. Okay. So make sure you guys know how to do this, especially using a unit circle. It's not difficult. And don't forget, can you use a unit circle in your test? Yes, you can.
But not this one.
But no, make sure it's no coordinates, nothing on it. It's just a blank unit circle. You can use that in your test. So that's it. Today is a test time. If you have this, I will say before the test, I want everyone here to show me the unit circle. You just grab it out and then put it in front of me. Then I say, all right, just now say, all right, Sally is good, Ashley is good, Sam is good. So I will just go through all your names and then after that, you can start working on your test. Make sure I want it to be not like this. Make sure it's no coordinates. I think I told you before, right? All right, next thing we're going to talk about is 6.6. 6.6. So 6.6 is where we will begin to use the inverse trigonometric function. The question is 19 and 29. So I'm going to look at 19 and 29 here. Okay. So this is the arc cosine graph. So I want to point out to you guys that you do not need to worry about graphing this arc sine or arc cosine or arc tangent. So, in order for you to do this, you have to do the opposite. Okay. So at -1, what is this value is? So again, we will need a unit circle approach here. Okay. Do not forget that when you do the arc cosine, what happened is all your XY coordinates is been switched around. So if you have, so last time when you do this, sine theta is Y. So when you do the arc sine theta, this will be your X because it's switched around. Okay. And when you do the arc cosine theta, this will be your Y. And then if you do the arctan, then this will be X over Y. So don't forget that when you do your arc, all your coordinate X, Y is being switched. Okay, arc is inverse. So can someone tell me, this is arc cosine, right? So which is Y. Can someone tell me which one of these, the Y value is -1?
3 pi over 2.
The Y value. So if you look at this is -1, right? What is a Y value in this case?
Pi.
Pi. So your answer here will be pi. How about -1/2? This is -1/2, right? -1/2 is this. So can someone tell me what is -1/2 in this case? Anyone know what is -1/2 in this case? Anyone? Which will be negative. So this is pi. This is kind of, yeah, we had to use this graph actually. Don't use a unit circle. So this is -1/2. So this is pi over something. Someone tell me pi over. This is pi over 2. Negative 1/2 is here. I think it's pi over 2 pi. Oh, it's right over here. Negative 1/2 is this one. So it's 2 pi over 3. 2 pi over 3. And then for pi over 3, which is this one, your answer will be 1/2. Okay. So what happenings in this case is your x and y coordinates is switched. So actually it's not using this one. Actually it's the same. I think they are the same. Yep. This is the same, but you just, sorry, this is the same. So what you do in this case is you just move the sign over. Yeah. So in this case, it is the same as your yx and y over x, but you have to read it backwards. So like cosine theta is x, which is this one. So that's why when it's -1 is pi. The next one we have is negative 1/2. Negative 1/2 is this one. So it's 2 pi over 3. And next one is pi over 3. Pi over 3 in this case is 1/2. So this is how we do question number 19. Again, I'm not calling you guys to graph this. So make sure you, the only thing you need to know about this arc sine, arc cosine, arc tangent is they switch around. And then 29 is the one probably you will get in my homework. So this is, yep, this is the one. Okay. So if you have, this is very important. So if you have the same thing like cotangent of, oh, this is arctangent. So this is different. So if you have, let me just do it again, a tangent with the arctangent of 12/5. So if they are like, because tangent, arctangent, they are like reversible, you can cancel it and you get 12/5. Okay. But since this, so if you have sine of arc of sine 12/5, anyone know what is this is?
12/5.
And that will be wrong. Okay. So what happens here? Why this is right? Why this is wrong? Because of the domain issue. So if you remember last time that when you do your arc sine, your domain can only take from -1 to 1. Right? Your domain can take -1 to 1. Can someone tell me where is 12/5 if you put in decimal? 12/5 is
2 point something.
2 point something. Is this in or outside the domain?
Outside.
It's outside. So this is D and E. But tangent is special because if you look at the domain for tangent, arctangent, the domain is what? All real numbers. So that means this works. You guys okay here? Let's give you another one. Cosine is also having, so sine and cosine have the same domain here. So let's do cosine, arc cosine of -1/2. What is this? So they will cancel. What you get? -1/2. So my question is -1/2 falls in or outside this domain?
It's in it.
So that means this is good. You guys all right here? Tough? Next, now this is 10 arctan. So now I'm going to do the opposite. Arctan 10 pi over 6. So if I do opposite, then this will be in degree, in radian form, in angle form. But if I do this in the other way, then this will be in the number form. So make sure you guys know that. And when you do this, we don't look at the domain anymore. You will look at the range. And so again, the arctan and 10 will cancel. You get pi over 6. Can someone tell me what is the range of 10 arctan? So for arctan, the range is between what? Negative pi over 2 to pi over 2. So my question is this inside this range?
Yes.
So that means this is your answer. Okay. Let me give you another one. So again, this arctan and tan, they can cancel out. So this is 11 pi over 3. So my question is 11 pi over 3 inside this range? So if you want, you can look at a unit circle. Where is 11 pi over 3 is? 11 pi over 3. Ooh, this is a lot of circles here. How many circles do we need to go through? So one full circles is 2 pi. 2 pi is what? 6 pi over 3, right? So where is 11 pi over 3? It goes all the way till here. This is 11 pi over 3. Is this inside this range? No. So can someone figure out what is 11? This is not DNE. This one does exist. And this one, it goes this way, clockwise. Does anyone know what angle is that one? If this is 11 pi over 3.
Pi over 3?
Pi over 3 is positive, but this is going this way, so it should be what?
Pi over 3.
So this will become negative pi over 3. Is negative pi over 3 inside this range?
Yes.
Yes. So this is how you figure out for this case. It's difficult. It's not easy. It's easy. Let's do the sine one. Arc sine of sine, let's say 3 pi over 4. So this will cancel. You will get 3 pi over 4. Does anyone remember what is the range? Because now we're talking about range. The range of sine. So if you look at the notes, the sine, the arc sine, the range is also the same as your tangent, which is what? Negative pi over 2 to pi over 2. So my question is 3 pi over 4 inside this range?
No.
No, because 3 pi over 4 is here. The range is from pi over to pi to negative. So how can you make him? So this is 3 pi over 4 is this one. This is 3 pi over 4. So how you figure out is figure out the reference angle. So what is this angle is? If that is 3 pi over 4.
Pi over 4?
Yep. So this is pi over 4. And is pi over 4 inside this range? Yes. So make sure you guys know when I do switch around, you can cancel it. And then if this is not inside that specific range, draw a picture. And then once you draw the picture, you can figure out if it's here, you go negative. If it's here, you go positive. Okay. Let's do cosine, because cosine is special. Let's go back 3 pi over 4. So cancel this 2, you get 3 pi over 4, right? Does anyone know what is the range for cosine? It's not this. This is only for tangent and arc sine. For arc cosine, your range is what? Between 0 and pi. 0 and pi. So my question to you is 0 and pi. Is 3 pi over 4 inside this range?
Yes.
Yes, so this is your answer. And let's do one more. Arc cosine. Cosine of 7 pi over 3. So this will cancel. So you will get 7 pi over 3. So this 7 pi over 3 is not in 0 to pi. So if you draw the picture, this is 6 pi over 3, which is 2 pi. So 7 pi over 3 is a tad bit more like this. So this is 7 pi over 3. So can someone tell me what angles 4, 7 with the 7 pi over 3? Now you don't do this one because we don't want to find that. So don't do this because we always count. If you want to do it, you always do it from the x-axis, not from the y-axis. So never do your calculation from the y-axis. You always do it from the x-axis. So what is the angle for this one? And that will be your answer. Anyone?
Pi.
Hmm?
Pi over 3.
Yep. So this is pi over 3. So so make sure you guys know how to do this. And this is only happens if they are the same. Okay. But for question 29, unfortunately 29, they are not the same because in question 29, you got the cotangent and you got the arctangent. So if you don't have the same, then you cannot cancel like what we did here. So you do a triangle. Remember your SOHCAHTOA? So we will use SOHCAHTOA. So let theta to become the arctangent. I'll just use this one of 12 over 5. So I will let theta to become him. Okay. And as you know that I can move the arctangent back. So like equation. So when you move the arctangent back, you will get tangent theta equals to 12/5. So with this, you can draw me a right triangle. This is tangent. So 12 in this case is your opposite. 5 in this case is your adjacent. So this is 12 is opposite. 5 is adjacent. Can someone tell me what is your hypotenuse in this case?
13.
5, 12,
13.
13. So this is become cotangent theta. Since this whole thing is theta, so now it's cotangent theta. Cotangent theta is what over what? Not opposite over adjacent, is what? Adjacent over opposite, right? And what is adjacent in this case?
5.
And over by 12.
12.
So your answer in this case is 5/12. Okay, so if you find out they are different like this, then you have to draw a right triangle. Now for 30 and 31, you have to use x on it. So instead of 5 and 12, you will get like x and 1. So this time you have to use the Pythagorean theorem, x squared plus 1. A squared plus B squared equals to C squared. So when you do like question number 30, it's going to be icky. So I'm going to show you how to do question number 30. And this is all calculus type. So when you go to calculus, you will see all this again. Okay. So I'm going to use arctangent x. Okay. So if you have a number, like all this has a number, then your answer will be a number. But if you have a variable x on it, so you have to use, again, you let theta become the arctangent of x. So when you move back over here, you get tangent theta equals to x. So when you draw me the right triangle, sorry, this is not like a right triangle. This is x over 1. So your opposite is x, your adjacent is 1. And in order for us to find your hypotenuse is a squared plus b squared. X squared plus 1 or 1 squared, 1 plus x squared, doesn't matter which one you put. So what happens now is because this is theta, so you will get sine theta. And does anyone remember sine theta? So SOHCAHTOA is opposite over hypotenuse. Which one is opposite if you look at this question, this triangle? Opposite in this case is x. And hypotenuse is the square root of x squared plus 1. And this is your answer in this case. So if you have x terms, then you have to use the answer will be. So your answer will be x divided by the square root of x squared plus 1. And again, this is all calculus type questions. Anyone have any questions so far?
When they're different, like arctan and sine, you don't look at the range, right?
No.
The
So
domain.
if they have a different different things like this, you do not need to worry about the range and domain.
Okay.
Okay. So if they are different, you don't need to worry. But if they are the same, like this, then you need to worry about. Like here, because of this, you have to worry about range because it's in angle form. Okay. But once they are different, then you just do this, like what I'm doing. You do not worry about domain and range. You guys all right? Okay. Next we're going to talk about is starting chapter 7. So so this is something that very important. So chapter 7 is full with fundamental identities for trigonometry. So this is the killing chapter. So I just want to point out to you guys that make sure you practice a bit more than this. So first thing you have here is a bunch of identities. These identities, you have to memorize them. Some of them you already know. Some of them you do not know. You have to memorize this. The first one is a reciprocal identities. This one I think you guys know, right? Sine is the same thing as 1 over cosecant. Cosecant is the same thing as 1 over sine, right? Cosecant and sine are reciprocal. Cos and secant is reciprocal. Tangent and cotangent reciprocal. You guys know this because we're doing that a lot. That one, understand. You guys should be able to do this. Quotient identities. Quotient means fraction. So tangent is sine over cos. Cotangent is cos over sine. So quotient identity can be only used for tangent and cotangent, and they will change it to become sine and cos. Okay. Next, it's Pythagorean identity. Pythagorean identity comes from the Pythagorean theorem. So it's sine theta plus sine square theta plus cosine square theta equals to 1. So you see I put stars on it, please means that it's important. So once you get this, you can get the other two easily by dividing. Okay. So once you know it's sine square plus cosine square equals to 1. So you want to know the other one. So if let's say you want to know this one, secant is 1 over cos. So what I did here is I divide everything here by cosine. And if I divide everything here by cosine, sine over cosine is tangent. Okay, so sine over cosine, you will get tangent square. Cosine cancel out, become 1. 1 over cosine is secant square. So that's how you get your second formula here. Okay, I take this formula and I divide this by cosine square. And that's how I get into this. And if I want to get into the other formula, so instead of dividing cosine square, I will dividing with what? Sine square. And sine over sine is 1. Cosine over sine is cotangent square. And 1 over sine is cosecant square. So this is where you get the third formula, 1 plus cotangent square equals to cosecant square. So again, class, this Pythagorean identity is very important. And I will recommend you to memorize the first one. And if you want to derive the other two, either you divide everything by sine or you divide everything by cosine, and then you will get the other two formulas. Are you guys with me? Co-functions. Co-function is what you guys did before in 7.3. When you have a co-functions, you can use the addition of the two has to be 90 degrees. For example, is sine and cosine is co-function. So sine 60 is the same thing as cosine 30. That means if you add these two numbers, two angles together, it will be complementary, means 90 degrees. Okay. Tangent and cotangent is co-functions. Secant and cosecant is co-function. Remember last time I asked you to find cotangent 40 degrees. Cotangent 40 degrees is the same thing as tangent what? So again, the total has to be 90. So what is complementary of 40?
50.
50, yeah. So this is what we call as cofunctions. So tangent and cotangent has to be cofunction, and secant and cosecant also has to be add up to be 90 degrees. Okay. The last one is even and odd identity. What is even and odd identity is negative. Your theta is negative. That means your angle is negative angle. So if you have a cosine or secant with a negative angle, that negative angle is disappeared. So you get cosine theta and secant theta. This is what we call as even function. But for sine, tangent, cosecant, cotangent, if you have a negative angle in there, this negative angle, you can pull it out. So sine negative theta is the same thing as negative sine theta. Same thing for tangent negative theta, cosecant and cotangent negative theta. This is what we call as odd function. Okay, so this is all the identities here. So you need to know this. This is very important. So one of thing is, if you even know this, the question is, how do you apply this? Okay, this is more important. Some of you just memorize this, but doesn't know how to apply it. So in the test, useless. Okay, so you need to know how to apply it. So for the reciprocal identity, in order for you to apply this, okay, for when you apply this, you have to take the reciprocal. So example is the reciprocal of it. Okay, and also I want to point out to you that all this identity you can actually perform solving. So we know that sine theta is 1 over cosecant theta, but if you multiply cosecant theta to here, so sine theta times cosecant theta is equals to 1. You guys with me here? So that means that if you see this identity is not fixed, you can actually perform solving. So you can move the cosecant theta here, you can move the sine theta there, you can move. So you can actually move things around here. So this is the usual reciprocal is when you have sine and cosecant, like, you know, those are reciprocal to each other. For quotient is you have tangent or cotangent. You have to change this into sine cosine. So yes, let's say you got a function that is tangent and you want to change that tangent function to sine or cosine function, we will use this quotient identity. And again, as usual, if you look at tangent, so tangent theta is sine over cosine. So I can move the cosine over. So tangent theta times cosine theta is equal to sine theta. So what I'm telling you here, class, is this kind of identity is not fixed. You can actually add or subtract or multiply, like performing solving equation. Like, you know, if you add both sides. If you subtract, you subtract both sides. And then Pythagorean identity, the useful for this is when you see square. This is the only time that the only identity that you have square. So if you have any equations or anything you want to solve or prove or anything, if you see square on it, you always will look at Pythagorean. You don't look at the rest of it because Pythagorean is the one that having square on it. So again, if you look at sine square plus cosine square equals to 1, you can always move things around, like solving equation. So I can move the cosine over. So sine square in this case is 1 minus cosine square. You guys with me here? So that means that this kind of identity you can move around. So it's not fixed. For example, that the tangent one, 1 plus tangent square equals to secant square. I can move the tangent around. So it becomes 1 minus 1 equals to secant square minus tangent square. So what I'm pointing out in this class is this formula, the identity that you see here, you can always move the 1 over, or you can move the secant over, or cosine over, or whatever over to make a new Pythagorean identity. It's still called Pythagorean identity, but it's move over. Okay, same thing with Pythagorean formula. A square equals to b square plus c square. You can always move things around. You can still call Pythagorean theorem as what I'm talking about. A square plus b square equals to c square. This is Pythagorean theorem. So I can move the b over there. So a squared equals to c squared minus b squared is also called Pythagorean theorem. I just move it all to the other side. Same thing happens to all this identity you see here. You can always move things around. So please, this is what I told you guys is you have to think outside the box. So that means that don't just look at this identity and think that all this identity is fixed. You can actually move things like that. Okay, that's what I want to tell you. And in order for you to use Pythagorean, you have square. A call function is used when you have a 90 degrees pop up like this. Okay, so when anytime you use a call functions, you have a 90 degrees pop up or pi over 2, which is the same thing as 90 degrees in gradient. And anytime you see this 90 degrees minus something, that is useful of call function. Even odd identity is used when you have your angle is negative. Okay, so how do we apply this even odd identity is, let's say you want to find cosine of negative 60 degrees. Because cosine of negative, if you use an even odd, it's an even function, that negative will disappear. So if you want to find cosine negative 60 degrees, this is the same thing as cosine 60 degrees. And if you use your unit circle approach, cosine 60 degrees is 60 degrees. This one, cosine is x, is 1/2. So this also will be 1/2. You guys with me here? Okay, so this is used when your angle is negative. Example is tangent negative 120 degrees. So instead of you doing clockwise and counterclockwise, you know, your angles, a lot of people doesn't like negative. You like positive, you don't like the negative angles. So what happens here is because tangent, you have negative, that negative, you can take it out. So this is actually is negative tangent of 120. And then you use a unit circle approach. Tangent 120 is this one. Tangent is y over x, so is this over that. So it will be square root of 3 over 2 minus over by 1/2. Now, don't put a negative here. It's because we know that it's a negative. Don't put negative and negative. You only have one negative here. That means this answer. Oh no, you have no. Sorry, this is negative. Sorry. Yep, you have to follow. So this is square of 3 over 2 with negative 1/2, and then this is negative. So these two negative will become positive, and then these two will cancel out. So your answer is 3. Because negative 120 is in quadrant 3, and quadrant 3 should be positive for tangent. Okay, you guys got what I'm trying to say here? So so this even odd identity is used a lot, especially when your angle is negative. Okay. The first few questions, they want you to use a fundamental identity. I do not want you to do that. Just use your SOHCAHTOA to do it. Okay. For example, here is don't look at all this work because it's messy. Because in the test, I won't ask you to do that. So the first question is, if I give you this, cosecant theta is 25 over 7. And tangent theta is less than 0. The quadrant involved, what quadrant is this belongs to is cosecant is positive. So it's quadrant 2 and quadrant 1, because cosecant is the same thing as sine, is positive here. And then tangent is negative in quadrant 2 and quadrant 4, because these are the one that makes it negative. So the one that has 2 of them is quadrant 2. So this is a quadrant 2 in this case. This is done back way in 6.2 or 3. Let me go back to 6 point something. This is where you guys learned last time in 6.3 actually. Yep, 6.3 in your homework. I teach you guys that what quadrant is that belongs to, and you just put it down. So in 6.3, you learn this in 6.3. And then what you do here is exactly like 6.3 you guys did. So this is exactly what you guys did in 6.3. But use back again here in 6.4. Remember this, what you guys did in 6.3? Which quadrant makes these two lines? So this is the same thing. Okay. So what you need to do next here is once you finish this, then you use your SOHCAHTOA. So cosecant theta is 25 over, so sine the reciprocal, you flip it, is 7 over 25. And then you draw yourself a right triangle. Oh, sorry, this is quadrant 2. Quadrant 2, don't forget, this is a ribbon. Remember the ribbon? So quadrant 2 will look something like this. Sine will be 7, which is the opposite over the hypotenuse. So now you need to figure out what is your adjacent is. You guys know what's the adjacent? 7, what? 25. Anyone know the triplets? 7, 24, and 25. And this 24 has to be negative because it's in quadrant 2. So once you know this, you can find what is your cosine theta. What's cosine is? This adjacent over by hypotenuse, so you get negative 24 over 25. And then you use a tangent. Then you use your SOHCAHTOA to do the rest of it. So you do not need to do like what I did here using this one. You can if you want to, but you can also use back what you learned in 6.3 to do this homework. Okay. The most important part of this kind of homework is how do you factor and how do you use simplifying, because that is used a lot when you guys do 7.2, when you prove identity. So I'm going to show you some of your homework here that you guys will see using 7.1. I'm going to take attendance here, so make sure you guys put present attendance time. So make sure you guys have put present on it. Attendance, you guys know what to do with attendance, right? Anyone have any questions for me before we continue? Yes, the blank unit circle is in D2L. If you want it, you can ask for me. I can always send it to you. So any documents is all in D2L. Now, so the first few are all pretty straightforward type where you use the identity to write down. So again, pi over 2 is the same thing as 90 degrees. So this is using like a Pythagorean. Again, this you have to use your SOHCAHTOA. So tangent theta is 8 over 15. Cosine theta is 17 over. Can you tell me what quadrant is this belongs to? Question 7. What quadrant is this belongs to?
Quadrant 1.
Quadrant 1. Yep, that is correct. That is quadrant 1. So this is a quadrant 1. Tangent theta is 8 over 15. So the opposite is 8. The adjacent is 15. And then you use your Pythagorean theorem, and this will become 17. And the rest of them, you can always do your SOHCAHTOA. Okay. Anyone know what is number 8, what quadrant is? Because if you give me the wrong quadrant, everything is wrong. Quadrant secant is negative, and tangent is also negative. What quadrant does this belongs to?
2.
Okay. Secant is negative is 2 and 3. Tangent is less than 0 means negative is 2 and 4. So this is quadrant 2. And then again, this is like this. This quadrant 2. Secant is the opposite of cosine. So cosine theta will be what? Negative 2 over 5. So negative 2 is an adjacent, 5 is a hypotenuse, and then you use a Pythagorean theorem to figure out what's your opposite, and then after that, SOHCAHTOA the whole thing. So it's pretty much the same thing what you guys did in 6.3. Okay. Mainly what you guys need to do next is doing this kind of simplified form. Okay, so what is cotangent square theta x minus cosecant square x? Now, once you see the square involved, is which identity you're looking for?
Pythagorean.
The Pythagorean one. Yes, you were looking for the Pythagorean one. So which is one of this one? There are three. So which one of this one using cotangent minus cosecant? The third one, right? But you have to move things around. So in your Pythagorean theorem, you get 1 plus cotangent square equals to cosecant square, right? Can someone help me to move this around so you will end up with this? So what do? I have to move the cosecant square over here, right? And then what happens to the 1? I have to move it there. So what is cotangent square x minus? Because when you move, the plus become minus. What is this going to be? 1 or negative 1?
Negative 1.
This is a negative 1. Yep. So your answer in this case is negative 1. So what is going on in here is mostly everything you see here is they want you to use the identity that you guys learned here and apply it. So can someone tell me what is secant x times cosine x? Which identity should we use here? Reciprocal, quotient, Pythagorean, or even odd? Secant x times cosine x.
Reciprocal.
Reciprocal, because we got secant, and so when you multiply cosine over there, so what is secant x times cosine x?
So it's 1.
Is 1. Yep. Okay. This one is a little bit tough. So again, which do you do for the top one? Cosine square pi over 2 minus x over cosine x. So every time when you see pi over 2, which identity would you use?
Cofunction.
Cofunction. So cosine of pi over 2 is the same thing as what? Sine. So this whole thing is the same thing as sine square x. Okay, because you have a square here. So you have a, and then this is over by cosine x. Still need to do a bit more work. So this sine square x, I can separate them. So this will become sine x times sine x over by cosine x. And then what you do here is you can take one of this. And what is sine x over cosine x? It's one of the identity again. This is give us
tangent
x. And don't forget, you still have what left over? The sine x left over. So your answer in this case is tangent x times sine x, which is this one. So what I'm doing here is what I'm calling proof identity. So in the test, I will take this and equals to sine x and cosine. I will say cosine, the whole thing equals to sine. You have to prove it. And how do you prove it? This is how you prove it. Written down like what I just written down here. So in your test, there will be proving question like that. Okay. The next thing we can do also beside using identities, you can factor. So if you are very weak in factoring, this will be really tough for you. So like number 14, 6 secant square x minus 6 over by secant x minus 1. So see, they call you to factor. See that? Because in the test, I won't call you to factor. I will say 6 secant x minus 6 over by secant x. This is equal to 6 times secant x plus 1. I want you to prove this. Okay, so this is actually 7.2 homework. So what happens in 7.1 and 7, they are very similar. The only thing in 7.2, you have to prove it. 7.1, you just need to pick the answer. And the answer is this. So how do you prove this? How do you prove this is equal to that? You have to factor. So can someone tell me what can you factor here?
Take a 6 out.
You can factor the 6 out. You will get secant square x minus 1. Now you cannot cancel here because this is no square. But can you factor this somewhat? This one still can be factored. Anyone know what is secant square x minus 1 when you factor it? Do you know how to factor x squared minus 1? What's a factor for x squared minus 1?
X plus 1, x minus 1.
So this will become secant x minus 1 and then secant x plus 1. And this is all over by secant x minus 1. Now what you do is these two is cancel out. So what you left is this 6 secant x plus 1. You do not need to distribute it if you know. What I'm testing you is how you prove this. So in 7.2, this is what you guys doing in my homework. So that's why 7.1 and 7.2 is very similar. So for this case, you have to type 6 times secant x. Make sure you put parentheses on it, minus 1. And minus 1 plus 1. And if they mark you wrong, you just need to distribute your 6. I don't know, they should mark you right. Yep. Anyone know how to factor the next one? This is all factoring, so that's why the next one, number 15. Anyone? So in order to factor, you always put the highest power first. So it's cosine 4x minus 2 cosine square x plus 1. So if you doesn't know how to factor this one, x4 minus 2x squared plus 1. I just get rid of all the costs. So if you know how to factor this, you should know how to factor that. So do you know how to, if you doesn't know how to factor this, say goodbye to this class. I can tell you right away. So how do you factor this one? To make x for,
X minus 1, x squared minus 1.
And then?
X squared minus 1.
Very good. Okay, so this one, and guess what? X squared minus 1 here can be factored some more, right? So this will be x minus 1 and x plus 1, right? And this one still can be factored some more. So you get x squared minus 1 squared and x squared plus 1 squared, because this 2 is the same factor. Okay. So now what you got when you factor this one. Same thing. So x squared minus 1, this will be what? Cosine square x minus 1 and cosine square x minus 1. Okay, because it's instead of x squared, I use cosine square x. We have a Pythagorean identity to use here. So can someone tell me which Pythagorean identity should we use for cosine square x minus 1? That's my Pythagorean. It's not popping up. Where are you hiding? Oh, he's hiding over here. Which one is cosine square x? It's going to be this one, right? But you have to switch around. So sine square plus cosine square is equals to 1. But I'm looking for cosine square x minus 1. So how do you switch this to become him? What do you need to move around? The 1 has to move here, right? And the sine has to move there. So what is cosine square x minus 1 is? Anyone?
Negative sign.
Very good. Negative sine square x. And this one is also negative sine square x because they're the same. Now you can multiply. What happens when you multiply two negative? That will become positive. So what is sine square x times sine square x? Sine 4x. So this is your answer for question number 15. You guys with me? Sine. Oh, how do you put this there? You put the power first. This is going to be, let me see. And function power. Where's my power? Maybe use, let me see. Sine 4. They didn't like me. How do you put this? Trig. There you go. Sine 4. There you go. X. So in order for you to make power, you use the caret shift 6. You guys okay here? So it's a bit, make sure you know how to type this one out. Sine 4x. You guys all right here? Tough. Yeah, you need to know all this. This is, chapter 7 is a difficult one. Cosecant 4x minus cotangent 4x. So this one looks like x4 minus y4. Do you guys know how to factor x4 minus y4? X squared minus y squared and x squared plus y squared, right? So what is a factor for this one? Cosecant square x minus cotangent square x. The same thing, cosecant square x plus cotangent square x. But then you have to use your Pythagorean identity because they have square. So yeah, some students ask me which identity we use a lot. You can tell already, Pythagorean. Yep. So we use this Pythagorean identity because it's having cotangent and cosecant. So can someone tell me what is cotangent square x minus cosecant square x minus cotangent square x? Yes. So we just need to move your cotangent over there, right? So what is cosecant square x minus cotangent square x? You get exactly 1. Because if you move this over there, you get 1 equals to cosecant square x minus. How about this one? Do you have an identity for cosecant square x with a cotangent square x? Plus. Can we make that from this identity? If you move things around, can you make cosecant plus cotangent? The answer is no. Because if you move, the cosecant is negative, right? If you move, the cotangent is negative. You cannot make both of them positive. So in this case, this one has no identity. So your answer in this case is cosecant square x plus cotangent square x. Because you multiply this by 1, and anything multiplied by 1, you get back the same thing. So for that, you will get this answer. So this will become cosecant square x. We should move it back. Close the parentheses, and then plus cotangent square x. Questions? And this is the last one. So your online homework is 7.1 and 7.2 because they are very similar, as you guys can see that. What happens in 7.2 is they will make something like this, and then they will make one of this blank. So when you do your 7.2 homework, they will make one of this blank. You have to fill, this one is equal to blank and this one. So you have to fill in what is this one. And this one will be cosecant square x minus cotangent square x. So they are blank. So it's mostly the same thing, but then you just fill in the blank. Number 17. Do you guys know how to factor that fellow? Five sine square x minus 8 sine x minus 4. So this is the same thing as 5x squared minus 8x minus 4. If you know how to factor this one, you should know how to factor here. So anyone know how to factor 5x squared minus 8x minus 4? In class, this is very, very important because whole chapter 7 is all like this. So 5x squared is 5x and x. Anyone know what to do with 4 here? 2 and 2, right? And minus, so one of them has to be plus, one of them has to be minus. And how do you check if this is a correct factor? You just what? For it out. So 5x times x is 5x squared. 5x times negative 2 is negative 10x. 2 times x is positive 2x, and you get negative 8x. This is correct. And then 2 and 2 will give you negative 4. So if this is a factor for him, then what is a factor for this one? Exactly the same, except you change your x to become sine x. So your answer in this case will be 5 sine x plus 2 and sine x minus 2. Now, we cannot use your Pythagorean identity in this case. It's because none of this is squared. So if none of this is squared, that's it. This is your answer. Okay, no Pythagorean identity. 18. Now, the difference between 17 and 18 is this. One of them has sine, and one of them is cos. So if it's a sine or cos, you can direct factor it. But what happens if you have one sine and one cos? Can you direct factor like this? The answer is no. So you have to change everything in terms of sine or everything in terms of cosine. So how do we do this case? We can change this into cosine using your Pythagorean identity. Your Pythagorean identity says sine squared plus cosine squared equals to 1. So we can do sine squared in this case is 1 minus cosine squared. So this is 1 minus cosine square x, and then the rest is just the same. And then you combine like terms, so negative cosine square x. Now that everything is in terms of cosine, then you can factor it. This is 12, because 1 plus 11 is 12. Now, since you have a negative in front, in order for you to factor, you have to take out the negative. Your leading coefficient is always has to be positive. So every time when you factor this number 5 has to be always positive. So if you have a negative like this case, you have to factor it out. And when you factor the negative out, all your sign inside there is changed. Now you can factor this for a while. And the negative is still there. So this is cos x and cos x. Can someone tell me what times what is 12? But when you add, you get 4, negative 4. So what times what is 12?
6 and 2.
6 and 2. And which one is positive and which one is negative? We need negative 4.
6 is negative.
And 2 will be positive.
Nope.
And again, you cannot use Pythagorean theorem here. It's because your cosine is now square. So this is your answer in this case. Don't forget the negative. And the rest, this one you need to FOIL. This one, like they call you to multiply. Multiply means you FOIL. So FOIL this one out. And then once you finish foiling, if you can use your, because when you FOIL, you got your square, right? And once you got square, you will use your Pythagorean theorem to reduce it. Okay, so go home and practice this. Class chapter 7, as I told you, is killing chapter. So your online homework due this coming Wednesday is 6.6, right? 6.5 and 6.6 is due tomorrow. 7.1 and 7.2 will be due on next Wednesday. Okay, and I still have a handful of you guys have not turned in that 3 pages scanning. I resend you guys an email for those students who have not do that. So if you have not turned in your 3 pages scanning, you have to turn it in again. This is for your testing, because in the test, you have to scan your paperwork. Some students ask me, what do you need to scan? Any 3 non-confidential papers, I don't care. Some of you scan recipes, some of you scan, I don't care. Because I just want you to know how you scan it, because in the test, you write all your stuff and then you scan it out. And then you upload it to D2L. That's how you submit your test. So that's why you guys need to practice this, because at the end, in the test, you don't have to worry about, oh, how do I scan this? How do I do this? Okay. So make sure you guys do. I think I got like 10 or 12 students of you haven't done yet. So please do so. I'm going to stop sharing and stop recording. Does anyone here have any questions in this case? Anyone have any questions for me?